Hello everyone, back with day 29 here. I'm going to look at review sheet problems 4, 5, 8, 9, 11. So just watch the video for the numbers that you have the most concern with. If you have concern with all of them, watch them all. Let's take a look at number 4. It says sine of xy plus 5x equals 9x squared. And our goal here is we want to find dy dx. Looking at this thing, the 5x and the 9x squared aren't going to give me any problems. The problems are going to come from this sine xy. So I see a function xy within another function sine. So I know I'm going to need the chain rule. But I'm also going to need to use the product rule for the derivative of xy. So here's what this is going to look like. For sine xy, I'm going to do the derivative of the outside with respect to the inside. So I start off cos of xy. Now I need to multiply by the derivative of the inside. Here's where we need to be very careful. The easiest way that you'll lose points here is if you forget to put this in parentheses. So I need to multiply by the derivative of xy. That's going to be a product rule, and so it's going to be a binomial. So I'm multiplying by a binomial, I need parentheses. So I'm going to put a parentheses. Now I'm going to have my first and my second. So I do the derivative of the first, which is 1, times the second, which is y, plus the first x times the derivative of the second, which is dy dx. Once again, that y plus x dy dx needs to be in parentheses. I'm just going to continue deriving. The rest are easy. Plus 5 equals 18x. The next thing I'm going to do here to get dy dx alone is I want to distribute that cosine of xy. When I do that, I like to make sure that I write my y in front of the cosine of xy. So I end up with y cosine xy plus x cosine xy dy dx. I always keep my dy dx at the back. Equals, I'm going to go ahead and move this over here too, equals 18x minus 5. I like to do that step to remove the parentheses just to make solving for dy dx a lot easier. Remember when things switch sides on equal signs, we have to switch signs. That plus 5 became a minus 5. Then I'm going to go ahead and subtract my y cosine xy, leaving this term alone because that's the term with the dy dx. So I end up with x cosine of xy dy dx equals 18x minus 5 minus y cosine of xy. Now, if you had these two terms flip-flopped, that's fine. It means the same thing, as long as they're both negative. Then I'm going to go ahead and divide by x cosine xy, and I get dy dx equals 18x minus 5 minus y cosine of xy, whole thing over x cosine of xy. And that doesn't simplify any more than that, so we leave it alone. That's problem 4. Let's take a look at problem 5. Once again, problem 5 is simply a find dy dx. This is a problem where simplification along the way is going to make this a lot easier. I realize I probably didn't give you enough space on your worksheet to complete this. On the quiz on Wednesday, I'll make sure that there's a little bit more space for you. So we look at this and we see what rules do we need. Well, that first term, 5y squared over 2x cubed, that's a quotient rule. The other two are simple enough. Just remember when we derive our 4y cubed, we got to multiply by dy dx. Okay, so quotient rule says I do the derivative of the top, which is 10y dy dx. Again, every time I derive y, I need to multiply by dy dx. That's the derivative of the top times the bottom. Minus the top times the derivative of the bottom, which is 6x squared, all divided by the bottom function quantity squared. So there's my whole quotient rule. It's pretty unsimplified right now. I'm going to simplify that in my next step. But I want to continue to do my derivative along the way here. My derivative of 4y cubed would be 12y squared dy dx. And that has to equal 12x. Before I do anything else here, I want to clean up that quotient, right? There's a lot of ugly stuff in there. I want to clean it up and get it to look as nice as I can. A couple things I like to do when I do this. I like to multiply my coefficients together to get one single coefficient out front. Then I usually follow alphabetical order. Put my x terms first, my y terms second, and if I have a dy dx, put that at the end. Also, I have a monomial squared that I want to take care of as well. So, here's what this looks like. I'm going to multiply the 2 and the 10 together to get 20. I'm going to put my x terms next, which is x cubed, then my y term, then my dy dx. I know that this whole sign is going to be minus over here. I'm going to multiply my 6 and my 5 and get 30. Then I'm going to put x squared first, then y squared second. You don't have to do it that way. It's just the way I like to do it to keep myself organized. And that's all divided by 2x cubed squared. Now we can't screw this up. 2x cubed squared. I'm going to square the 2 and get 4. And then power to a power multiplies the exponents. So I end up with 4x to the 6th. Okay, I'm going to continue to write the rest of the problem here. 12y squared dy dx equals 12x. Now what I saw some people doing today is they went ahead and just multiplied everything by 4x to the 6th. That works. However, you might make your life a little bit easier by simplifying that quotient right now. If I go ahead and simplify that quotient right now, I see that 20, 30, and 4 are all divisible by 2. So 20 divided by 2 is 10, 30 divided by 2 is 15, 4 divided by 2 is 2. Next thing I see is that all 3 terms have an x squared. So this whole x squared is gone. The x to the 6th becomes x to the 4th. X cubed becomes x to the 1st power. So I'm just going to cross that out. When rewriting this thing, I get 10xy dy dx minus 15y squared over 2x to the 4th. I like to do that step there because then the rest of the numbers are easier to work with, and I don't have to do as much simplifying at the very end. When you do that very carefully to make sure everything gets recorded correctly on your simplification. Now I'm going to multiply both sides of the equation by 2x to the 4th. I like to put parentheses here to remind myself to multiply this term by 2x to the 4th. Okay, sometimes we forget to do that. Then I'm going to multiply by 2x to the 4th over here. So this gets distributed to both of those. It's nice because it totally cancels, right? That's why we chose it. So we're left with 10xy dy dx minus 15y squared, just the numerator, plus, again, don't forget to multiply this by 2x to the 4th. That gives us 24 x to the 4th y squared dy dx equals 24x to the 5th. Now I see I have 3 terms on the left side. 2 of them have dy dx. That minus 15y squared doesn't, so I'm going to add the 15y squared over to the right side, and I'm left with this, 10xy dy dx plus 24x to the fourth y squared dy dx equals 24x to the fifth plus 15y squared. Now I'm going to factor out my dy dx and divide, and I'll get dy dx equals 24x to the fifth plus 15y squared. Whole thing divided by 10xy plus 24x to the fourth y squared. I do one more double check here to make sure nothing reduces. 10, 24, 24, 15. The only number that divides them all is 1. Make sure you don't make any simplification errors here by canceling things out when they can't be. Okay? You might say, oh, 24 and 15, they both divide by 3. Great, but 10 doesn't, so it doesn't work. They don't all have an x, they don't all have a y, so we can't simplify any x's or y's. That's our simplest answer right here. Great. Next problem. Number 8. I want the slope of the tangent line to x cubed minus 5xy plus y squared equals negative 13. I want this at the point 2, 3. So slope of the tangent line at a point, I want to find the derivative, right? That's code for derivative. I want to find the derivative and then plug in the point 2, 3. So going ahead and doing this, a couple of things to be worried about. This minus here messes up a lot of people. So we want to be very careful with that minus. I'm going to have a product rule there because of the 5x and y. And usually product rule we think, oh, that's plus, right? But think of that first term as a minus 5x. Think of that second term as y. So going ahead and getting dy dx here, I'm going to get 3x squared for my derivative of the first term. Now I'm going to execute the product rule. So I'm going to do the derivative of the first, which is negative 5, times the second, which is y. Now usually this is plus, but I'm going to plus a negative 5x. So I'm just going to write minus 5x, minus the first times the derivative of the second. These signs should need to both be minus here. If you wrote plus minus, that's fine. If you wrote minus and then parenthesis and there's a plus, that's fine, because when you distribute the minus, it'll become minus. Okay? Just be careful on that. Again, plus 2y dy dx equals 0. So I went ahead and did all of my derivatives of all the terms using the product rule when I needed it, being careful of that negative. Now I want to isolate dy dx. So I'm going to move these two terms to the other side, and I'm going to have negative 5x dy dx plus 2y dy dx equals negative 3x squared plus 5y. I'm doing this all very, very carefully. Now I'm going to factor out my dy dx and divide. And I'm going to get dy dx is negative 3x squared plus 5y over negative 5x plus 2y. Again, I can look to simplify here, but 3, 5, and 2 don't have a common factor other than 1. Not all the terms have an x, not all the terms have a y. It's as simplified as it's going to get. Right? I may be able to rewrite it in a slightly different way, but that's as simplified as it's going to get. Now I need to just go ahead and plug in. I want to evaluate dy dx, right, at the point 2, 3. So everywhere I see an x, I'm putting a 2. Everywhere I see a y, I'm putting a 3. Let me just do this very carefully. Now evaluating this thing carefully, I'm going to do 2 squared first. 2 squared is 4. 4 times negative 3 is negative 12. Plus 15. over negative 10 plus 6. Negative 12 plus 15 is 3. Negative 10 minus 6 is negative 4. So I get my answer, dy dx evaluated at 2, 3 equals negative 3/4. Great, next problem. Let's look at problem number 9. Problem number 9 is a tough one because I have to get to the second derivative and I have to evaluate it at the point negative 1, 1. So to get to the second derivative, I first have to get to the first derivative. And the most important thing here is simplify that first derivative. So here's my first derivative. I got 8x, nothing fancy there, plus 16y dy dx equals 0. Nothing too crazy there, no product rule, no chain rule, no quotient rule. Just have to remember when I derive y, I get dy dx. Now I'm going to subtract 8x and divide by 16y, and I get dy dx equals negative 8x over 16y. Please, for your own sake, please, 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 simplify dy dx here. Your life will be so much easier if you make that move. Now I like to circle my dy dx when I'm done with the first derivative, and I got the most simple form. Now I'm going to go ahead and do this, execute the second derivative. That's going to require a quotient rule here. So I do the derivative of the top, which is negative 1 times the bottom, which is 2y, minus the top times the derivative of the bottom, which is 2 dy dx. Don't forget about tacking on your dy dx, even when we're doing the second derivative. Anytime we do derivative of y, whole thing divided by 2y quantity squared. Cleaning this up a little bit, I get my second derivative is equal to negative 2y. This is going to end up being a plus 2x dy dx. Whole thing over 4y squared. Now, if you want here, we can make a simplification. If we make that simplification, I notice that 2, 2, and 4 are all divisible by 2. So I got negative y plus x dy dx, whole thing over 2y squared. If you didn't make that simplification, it's okay. You probably still will get the right answer. Now, that's the second derivative, but it's not in terms of x and y. It's in terms of x and y and dy dx. So I want to go back up here. My nice, convenient, please circle, negative x over 2y. And I'm going to plug that in here. Okay, so let me make sure I did that right. Negative x over 2y, negative x over 2y. Then cleaning this thing up, I got the second derivative equals negative y. This is now going to be minus. I multiply the tops and I get x squared. I multiply the bottom and I get 2y. All over 2y squared. Now I'm going to just multiply both the top and bottom by 2y. And on top I'll get negative 2y squared minus x squared over 4y to the third. So that's my most simplified version of the second derivative. Now I want to evaluate the second derivative. I'm not totally done yet. I have to evaluate the second derivative at, what was the point again? Negative 1, 1. So all my x's are becoming -1s, all my y's are becoming 1s. So I got -2 times 1 squared minus -1 squared over 4 times 1 cubed. Now I see sometimes people looking right here and they say, oh, that's +1. Be careful, we gotta follow PEMDAS. So we get -2 minus -1 squared is 1 over 4, and I get -3/4. Okay, the last problem I want to look at is problem 11, then we'll be done. Here I want to find the slope of the tangent line at the point 0, 2. Okay, this is a tough one because I got a chain rule within, right, or I got a quotient rule within a chain rule. So I got to be very careful here. This one's pretty easy to mess up. Probably the hardest problem on the review sheet. So when I go ahead and do this, I see chain rule first. I see a function within another function. So I do the derivative of the outside with respect to the inside. But then I need to multiply by the derivative of the inside. Well, the derivative of the inside is going to be a quotient rule. So I'm going to make sure to put my parentheses here because I'm going to have a big ugly quotient here. So I have to do the derivative of the inside, I need to do derivative of the top times the bottom minus top times derivative of the bottom over the bottom squared. So the derivative of the top is 1 times the bottom is y minus the top times the derivative of the bottom all over the bottom function squared. So that's the whole messy answer to the derivative of sine of x over y. I'm going to finish out my derivative here and got plus 4x minus 5, don't forget your dy dx, equals 0. Now, to get dy dx alone here can be kind of challenging. Okay? What I like to do is that whole first term is all connected with multiplication. So I can multiply by y squared right off the bat. So I'm going to multiply the whole left side of the equation here by y squared. I'm going to multiply the whole right side of the equation by y squared as well. And distribute it here, here, and here. When I multiply by y squared here, they cancel. And I'm left with cosine of x over y times y minus x dy dx. Now, if you don't like that, you're welcome to distribute the cosine first, but it only distributes to the top. You'll end up with the same thing. Okay? Plus 4xy squared minus 5y squared dy dx equals 0 times y squared. Hey, that's nice. That's just 0. Now I'm going to go ahead and distribute this cosine. I'll get y cosine of x over y minus x cosine of x over y dy dx plus 4xy squared minus 5y squared dy dx equals 0. Now I want the dy dx's on the same side, which they are. I notice they're both negative. I can make my life a little easier if I take these two dy dx terms and move them to the other side. Then everything is in a positive, which is just going to make life a little bit easier. So here's what I get. You don't have to do it this way, but this is how I like to do it. So I added my dy dx, the dy dx's were the ones I actually moved. Because then everything ends up plus, which is nice. Now I'm going to factor out my dy dx and divide. And I end up with y cosine x over y plus 4xy squared. Whole thing divided by x cosine of x over y plus 5y squared. And I'm dividing, or I'm evaluating this thing at the point 0, 2. So dy dx at 0, 2 is going, everywhere I see an x, I'm putting a 0. Everywhere I see a y, I'm putting a 2. So I'm going to have 2 cosine of 0 over 2 plus 4 times 0 times 2 squared divided by 0 times cosine of 0 over 2 plus 5 times 2 squared. Whenever you're evaluating things on the AP test with zeros, just do so very carefully. Multiplying by 0 makes the whole thing 0. But just remember that cosine of 0 is actually the number 1. Okay? These 0 over 2's are both 0, right? 0, 0. So I end up with 2 times 1, cosine of 0 is 1, plus 0. 4 times 0 times 2 squared is 0. All divided by, this whole term here is 0. Right? It's 0 times 1, but it's going to be 0. Plus 2 squared is 4. 4 times 5 is 20. So I end up with 2 over 0 plus 20 is 20. And I end up with 110. Some challenging problems in here, but ones that we can handle. Please comment on any other problems you want to see done. If nobody comments on problems they want to see, I'll just go ahead and pick some other ones that I think are challenging. All right, have a good day. 2 chains.